All right, hey y'all. So you have this with you, and I'm going through examples from this and going to give you problems to try. So the very first thing with the paragraph, it's the very first blank says a rational equation is an equation that contains one or more rational expressions. So the very first blank is rational equation, and a rational expression means has a variable either in the numerator or the denominator. And so your goal is to eliminate the fractions. So these are all going to have fractions, and there's two methods to use when you're solving rational equations. I'm going to show you both. Then read the next paragraph, and the next blank talks about excluded values, like extraneous solutions, excluded values. So the reason this is an excluded value is because it's when the denominator would equal 0. If you have a fraction, the denominator cannot equal 0 because that would be undefined. So an excluded value is those values, those x values that would make the denominator equal 0, and we're going to call those excluded values. And so you'll see beside each problem there's an EV, which stands for excluded values. So I'm going to skip number 1, because number 1 is just a proportion problem, and go to number 2. And so here it is. The excluded value is going to be 0 right here, because if x is 0, that would make it 0, and right here, the excluded value is when this entire expression would be 0. So when x minus 7 would equal 0. And that is when x is 7. So those are your two excluded values for number 2. When x is 0 and x is 7. And then one method is the proportion method. If you have a rational equation looking like this with no pluses or minuses out on the side, then you can solve it using a proportion method where you cross multiply. So I've cross multiplied 6 times this and 4 times x. And then you can see I've distributed and I've solved, and I got x is equal to 21. You always double check and make sure that your solution is not one of your excluded values. And in this case, 21 works, so that's why I checked it. So this is the proportion method. I'm going to show you number 3 on your worksheet. So I showed you number 2, and now I'm going to show you number 3. All right? So number 3, first we look at our denominator, and it's the same. So our excluded value is when x plus 4 equals 0, and that means x has to equal negative 4. So that's our excluded value, negative 4. I'm going to cross multiply, so negative 5 times this, and 1 times x plus 4. I distribute, and I get negative 5x minus 20 equals x plus 4. I subtracted x from this side, and then I added 20. And I get negative 6x equals 24. You divide both sides by negative 6, and x is equal to negative 4. But negative 4 is our excluded value. Therefore, there's no solution. If your answer is your excluded value, that means this rational equation has no solution, because the only number that we can put in to make this equal is negative 4. But you can't, because if you put negative 4 in, then that means it's undefined at that value. There's an asymptote, which means it approaches, but it never actually comes close. I mean, it never touches that line. So this answer has no solution. All right, so now I'm going to show you number 4 on that worksheet. And then you're going to try number 1, because number 1 is just a proportion. So we're going to look at the excluded values. Right here is a 6. Right here the excluded value is going to be negative 5, because negative 5 plus 5 is 0. We're going to cross multiply, and we get x times x plus 5 equals 6 times 6 is 36. Now when you distribute, you're going to have x squared plus 5x equals 36. We are going to have a quadratic in this case. We move over 36, and we have x squared plus 5x minus 36 equals 0. And we have a quadratic equation. So you can factor, you can use a quadratic formula, you can complete the square, whichever one you want to do. I'm going to factor, and I see that to get negative 36, I'm going to need 1 plus and 1 minus, and I want a positive 5. So I know I'm going to use 9 and negative 4. Because if you add 9 plus negative 4, that's going to give you a positive 5. From here, I know that x equals -9 and x equals 4. So I look, are any of these my excluded values? No, my excluded value is -5. Therefore, both of these are solutions to my rational equation, which means if it's a solution, if you plug this number into x, then these would equal, and if you plug this number into x, then it would equal. Okay? So you try number 1, it is a proportion. Pause the video, you try number 1. Give me the excluded value, and then give me your answer. All right, so the excluded value is 0, and then your answer is x equals 14. Okay? So, now, those were proportions. Now, the next examples I'm going to show you are on the next page, where you have the little paragraph at the top, and it's talking about the least common denominator, the LCD. To solve these problems, you have to use the LCD because of this -3 and this +4. Whenever you have that extra value in there, you cannot just use the proportion method. So I'm going to show you how to use the least common denominator. In number 5, I have 2 fractions, and it's nice because my denominator is the same. So in this one, my least common denominator is x, which means I'm going to multiply every term by x. So I'm going to put big parentheses around it, and I'm going to multiply each term by the least common denominator. When you do that, it cancels in a way of the division property, the denominator, because I'm just going to show you a quick example. Right here, x times 2 over x minus x times 3 equals x times 8 over x. So all I've done is I've distributed this x to all 3 values. I'm showing you how it works. I'm not going to show you every single time. When you do this, we can see the simplifying process, or it's like the multiplicative inverse. So I have an x up here and an x down here. So if I were to multiply this, I would get 2x over x. Well, x divided by x is 1, and then we're left with 2. These cancel out. X times 3, I don't have anything to cancel out, so that's minus 3x. And right here, x and x are going to cancel, and I'm left with 8. All right, so that's why you multiply by the least common denominator, so you can simplify that denominator to get rid of the fraction. So now I have an equation. I'm going to subtract 2 from both sides, and I get 6, and x equals -2. This was number 5 on your notes. Now I forgot to do the excluded value. Because x is on the denominator, the excluded value is 0. This is not the excluded value, so that means that is my solution. And you could check it by plugging in -2 to these values and then seeing if that works. But I multiplied everything by the least common denominator. Number 6. First thing we look at is the excluded value. So when would these denominators equal 0? And they're going to equal 0 when x is 3. So the excluded value is 3. I'm going to multiply everything by the denominator, x minus 3, x minus 3. Again, we have the same denominator. Now, I'm not going to show you all the steps like here. I'm just going to go ahead and do the simplifying, but I'll explain it. When you multiply this first term, 7x over x minus 3, the x minus 3 and x minus 3 are going to cancel, so I'm left with 7x, just like over here. This middle term doesn't have anything to cancel, so I'm going to have to keep it, just like over here. X times 3 gave me 3x, so over here it's going to be 4 times that. And then the last one, just like over here, this x and this x cancel. That means they divided out to be 1, and I was left with 8. The same process here. X minus 3 and x minus 3 are going to cancel, and I'm left with x plus 1. I need to do some distributing to simplify, and I get 7x plus 4x minus 12 equals x plus 1. I need to do some combining like terms. And then I need to solve it like variables on both sides. I'm going to do the minus x and then the plus 12. Divide both sides by 10 and you get x equals 1.3. It is not my excluded value. It does look a little weird because it's a decimal, but that's okay. If we were to plug that in, both of these sides would equal each other. okay? Not easy, but doable. So on this worksheet, I've shown you 5 and 6. Now I'm going to skip to number 9, but if you look at this worksheet, number 7 and 10 are the proportion method. So you can go back, and I want you to do 7 and 10, do the proportion method. I'm going to show you number 9, and then you're going to try number 8. So when you finish this video, you should have the 2 pages with a long paragraph and a little short paragraph. You should have these done. And now number 9. So when we look at our denominator, we see that we have the same denominator, and the excluded value is 1. That's 1 minus 1 would be 0. We're going to multiply this by x minus 1, and then we are going to distribute it to each term. I know that my x minus 1 here and my x minus 1 here are going to cancel out. So I'm left with 3x minus 2 times x minus 1. And then my x minus 1 here, my x minus 1 here are going to cancel out. I'm left with 10. Now when I say cancel out, that means they're going to divide out to equal 1. I need to distribute, and I get 2x, negative 2x plus 2. X plus 2 equals 10, and x equals 8. I check to see if it's my excluded value. It's not my excluded value, so that means the solution works for this rational equation. So you are going to try number 8 on here. You're going to multiply both sides by the least common denominator, and for number 8, you need to get the excluded value, and then you need to show me what x equals. Okay, so pause it, work that one out, and then I'm going to show you. I'm going to multiply everything by x plus 2, and I'm left with 4. And I went ahead and I distributed, and I got 3x plus 6. So x is equal to negative 1/3, and my excluded value is negative 2. So those would be your answers, negative 1/3, and your excluded value is negative 2. So here's what I want you to do. On your worksheet, make sure you go back and do 7 and 10, the proportions. And then if you look at the next page, 1 through 8, we are going to work on those in class tomorrow. And I have the answers here, so we're going to work on those in class tomorrow. And yeah, see you later.